So my cat Chunker has an automatic water fountain and an automatic dry food feeder, both of which he loves. Sometimes Chunker likes to have water in his dry food, like some kind of cat food cereal or soup. Unfortunately, I have to do this manually every time, and what's the whole point in having an automatic waterer and feeder if there's a manual step that requires me there every single time? It defeats the purpose. And unfortunately, there's no easy purchase that could move the water from my specific waterer to my specific feeder, so I decided to make it myself. The first step was to build the hardware. Now, I'm no electrical engineer, so this took some YouTube videos and documentation online before I really got a grasp of what I was doing. The cylinder you see at the edge of the table is the water pump. It's a motor that takes electricity and converts it into kinetic energy, in this case, the flow of water. Above the motor pump, there is a blue rectangle to the left and a small little black adapter to the right. That adapter will plug into a 12-volt power supply, which will power the motor, and the blue rectangle is what's known as a relay. It's basically just a switch, either power on or power off, just like a light switch in your home. And above the relay and adapter is the Raspberry Pi. It's just like a microcomputer that fits on one little board and has all the power necessary to run something as simple as, turning on or off a switch, but not enough power to do any kind of heavy-duty video editing or machine learning. The way we control whether or not the circuit is open or closed is through the relay, using the Raspberry Pi. You'll notice the orange and red wire connected to the relay and the Raspberry Pi. Well, that red wire is connected to the JD VCC, and it is 3.3 volts. The orange wire is connected to the VCC, and it is 5 volts. Finally, we get to the yellow and white wires. One of those is just a ground, and the other is the input. The input allows us to control whether we provide 3.3 volts or 5 volts to the relay via the Raspberry Pi. If you provide one of those voltages, it closes the circuit. If you provide another, it opens the circuit. In other words, if you give one voltage, then the circuit is closed, and that 12-volt adapter that's plugged into a power supply will power the motor. If you provide the other voltage, the circuit is broken, and that 12 volts of power is not reaching that motor. This is basically a complicated light switch that is now connected to a computer chip that I can connect to via the internet and control via code. Once all the wires and hardware were connected, it was time to test whether I could actually control turning on and off the relay. That red light you see turning on and off is signifying to us that the relay is being turned on and off. In other words, the test worked. Once we did that initial test that confirmed the hardware was wired correctly and the relay works like a light switch correctly, it was time to package everything in a little cardboard box, plug in that 12-volt motor, and see it work end to end. What I want to show off now is that I can log into the Raspberry Pi through the internet using just its host, which is, I have it saved here, but for the sake of showing everyone, you just type in the IP address, and you click open. You have to log in, and I have some credentials already set up to log in, and now I'm in. So basically this terminal screen shows that I'm logged into the Raspberry Pi through my Wi-Fi that's over there. But right now I'm on my desktop. And all I wanted to do was test it out. I want to see if I can get it to work now that it's actually hooked up to the relay and everything's plugged in. So let's see. Okay, cool. So it's working. The only thing is that I have it on the wrong ends, meaning that it's pulling air from one side and pumping it into the water. So let me fix that and I'll be right back. Okay, I'm back now. It's a simple matter of, see, software caused connection to abort. That's because I just had to unplug everything, because to make it switch directions from pumping from the left to the right or the right to the left is a simple matter of taking the alligator clips and switching the plus and minus, the positive and negative charge, to the opposite side. That switches the flow. But you don't want to do that unless you unplug everything. Otherwise, you might get a little zap. So that's why we just lost connection, because the Raspberry Pi was closed. And now I will connect again. Alright, it's pouring water. It's pretty slow. but it's pouring the water. That's awesome. That's really awesome. It's working. And now let me take that off. Make sure it stopped. It did. But Chunker's soup is ready. That's awesome. Once we knew that it worked end to end, it was time to write the code to automatically pour the water during Chunker's set feeding times. Once the code was written and tested, it was time to set the Raspberry Pi to run that code as soon as it booted up. No matter how simple the end result is, it feels great to see a project finally work. Mmm, yummy cat food soup just the way Chunker likes it.